Well, thank you very much, and I'd like to thank all of my esteemed co-speakers and the organisers for inviting me here in the first place. If Joseph Jossi felt like he was a bit out of place and the odd one out, I perhaps am even more so. I'm one of the grubby engineers that Christopher Pine talked about. So what I'd like to do is talk to you about international collaboration from the perspective of a manufacturer, someone within the supply chain, rather than as a government body. Thank you. Thank you. Or a satellite manufacturer. So, but before I do that, I'd just very briefly like to tell you who we actually are and what we do. So bear with me for the pitch. Okay. We are Teledyne Technologies. I started life in the space business 40 years ago, working for an organization called the English Electric Valve Company. It's been taken over by successive organizations, most recently Teledyne, which is a US organization. So now we count ourselves as part of a large conglomerate, which we can now draw upon the international resources of to satisfy our many customers. Teledyne itself is a $5.6 billion company in the US. We are part of the digital imaging part, which is over half of that. There are many employees worldwide, I don't know them all, and many manufacturing sites across North America, Europe, and elsewhere. We serve lots of markets. I won't go through this in great detail. Digital imaging obviously is now quite ubiquitous across the world for many things, but the things in particular are of interest to the audience here, I think, will be the fact that we manufacture detectors and detection subsystems specifically designed for space. And we also have a very strong machine vision arm where they manufacture literally millions of detectors and cameras for use in industrial machine vision, which leads nicely into the possibility of upscreening of those sensors into the space market. So we can come at the space imaging business from both ends. As I said, we're a US-owned organization within a conglomerate. Teledyne Digital Imaging has all of these different organizations within it. The top four are those which we particularly represent in the space market. Teledyne Dulcer in Canada, Teledyne E2V ourselves, mainly based in the UK, in Chelmsford, Teledyne Imaging Sensors, who make fabulous infrared imaging sensors out in Camarillo in California, and Teledyne Judson, also in the USA, who make a variety of infrared detectors and other subsystems. As I say, we serve many markets. We have detectors, cameras, a variety of upscreened and bespoke memories and FPGAs, consultancy and services. So I won't dwell on this. We have plenty of facilities. This is around the world, but in this case, particularly in the UK. And where we should finish this sales pitch is the global partnerships part. So yes, over many years, we've dealt with a wide variety of customers, from space agencies to prime contractors to instrument manufacturers, where, although at the outset we consider it to be a customer-supplier relationship, in practice, even in the old space world, it was very much a collaborative exercise. So particularly with the large space agencies and their large primes, because we make imaging detectors, which necessarily are a key part of any imaging system, we get nice, privileged access to the systems engineers and to the people making systems concepts. So we get to talk very collaboratively with the people who come up with the concepts for all of the new imaging systems that you see around. In many cases, not all, but in many cases in the old institutional space world, this would result in bespoke detectors particularly designed for the application for which they're needed, which is high cost, long lead time, and therefore not particularly appropriate for the new space environment. So what we're now seeing is how the collaborations need to change between a supplier and the customer base when we have a more agile, short lead time, lower cost environment, such as the new space environment. So the difference, quite obviously, is the products we have to supply can't now cost millions, generally. They have to be turned around within months, not many years, and they have to be relatively general purpose, therefore. So the bit that still exists, however, is how do you decide what is the most appropriate sensor technology to address a particular need? So that detailed collaboration with the customer and the customer's engineering base is still necessary as it was in the old space world. If anything, it's more important. Because within ISRO, for example, you have experts who know very well what it is they want and discuss with us in some depth how to go about designing it and improving it. In fact, we have a long-standing international collaboration with ISRO, whereby we use our CCD foundry to satisfy their design needs. So we collaborate on the design, and then we manufacture for them what they require. ISRO, of course, has many experts, but when you look at the new space environment, there aren't that many experts to go around. So we have to provide some of their expertise in a collaborative fashion so that our customers can procure what it is they require to the right quality level, the right cost and the right timescale. And that, for us, turns out to be quite a big challenge. And we're still looking for ways better to collaborate with a very diverse ecosystem of smaller companies who are looking for more and more integrated solutions for their satellites and constellations. So in future, what we will have to be doing, are now doing, is looking at ways of offering our, frankly, huge portfolio of different products in visible, infrared, X-rays, whatever, to find how we can expose all of that technology and that product background best to the new space environment. And I'd be very grateful if any of you have any good ideas how best we can go about that. So with that, I would say thank you very much.